Partial pressure is a very straightforward concept, as the name implies partial or a part of. So let's say 1 over x, depending on the number of parts, times the total pressure. That's it. So of course, in order to become a part, you gotta have at least 2 components or a mixture of gases. Of course, you can have 2, 3, 4, 5, even infinity gases, which is the notational pressure of the gas if it were alone occupied by the entire volume of the original mixture. So let's say we have this box which has the temperature and the volume fixed. So the partial pressure, let's say we have several. We have A, B, C, and D. So the partial pressure will be the same pressure if we take out D, L, and B and we leave alone A. Same temperature, same vapor. Of course, you know that the pressure needs to change. So this pressure will be the same as this one right here. It's the total pressure of an ideal gas mixture. And of course, if we were to get technical, the sum of all partial pressures will always be the total pressure in the system. And actually, this is the Dalton's model. So let's say that we have, as you can see, is the same volume for all of these guys right here. Maybe in some cases you have more substance. And let's assume this is at the same temperature. So let's say this will be P1. Say this is 2 atmospheres and this is 3 atmospheres. If you were to mix them all together, then you will have 1 atmosphere, 2 atmospheres, and 3 atmospheres. If you add this, a total of 6 atmospheres will be present. Now, Dalton's law is the way we calculate this. As stated before, you just need to add all the pressures. So by definition, if you want to calculate, or if you know that this is the same temperature and volume, so this right here, all molecules are experiencing the same temperature and volume in the box, and you know the total number of moles, and you know the moles of your species, let's say A, B, or C, then you can calculate this via mole fraction. So the mole fraction of my species I, and let's say this is 1/3, 1/3, 1/3, so this is 1 over 3. 1 plus 1 equals 3, so this is 1.3. And let's say that pressure we have 6 atmospheres, stated before. Then the pressure of I will be the molar fraction of I and the total pressure, which in this specific case will be 0.333 or 1/3 times 6 atmospheres. So technically speaking, this species I will have a partial pressure of 2 atmospheres. Here's a quick example: nitrogen, hydrogen, and ammonia, Harbour process. So the total pressure will be the individual pressures, and you can always solve for a given one. So let's say you are interested on the partial pressure of nitrogen. Well, you know that the total minus the addition of the nitrogen and the gas will give you the partial pressure of ammonia. You can do this for any single concept, as long as you know all the remaining variables.